Hello and welcome to our next unit in congruent triangles, or just triangles. We are working with two new ways to prove congruent triangles, and that is by ASA and AAS. If you know how to name SSS and SAS, this should also be obvious. We're working with something called angle side angle and angle side. Okay. So get this in your index, pause the video as needed, as well as the title. And let's jump into it. So, angle side angle. Oops. Angle side angle. And let's actually put that in parentheses just so we could see it written out. Angle side angle is another way to prove that triangles are congruent, and it states if two pairs of angles and one pair of included sides between two triangles are congruent, then the two triangles are congruent. Okay, so what does that mean? Well, if you take a look at a triangle, or two triangles, well, let's take a look at one for now. Let's call this DOG. Okay, and if we were to just put any two angle markers down, we would have the first two pairs of angles that are congruent, or two angles. Then the one side needs to be the included side, meaning it has to be sandwiched, just like how it is here in the name. The S is sandwiched between the two angles, and that only occurs in one place, segment DO. Okay, if it was anywhere else, it is not technically sandwiched between two angles because that third angle, that the actual angle is on the other side. So DO has to be the included angle in this particular diagram. And if we look, and if we make another triangle, it has to follow the exact same pattern. Okay, so for instance, if I put another triangle, let's call this ANT. I'm going to flip this around just a little bit. I'm going to put this tick marker for 1, and then this tick marker for 2. The included side of those two angles has to be NT. And we could then prove that these two triangles are in fact congruent because there are two pairs of congruent triangles between two triangles, and the included sides of them are also congruent. Okay, so if we had a triangle congruent statement, we could say then angle or triangle DOG is going to be congruent to triangle, and then this is where we fill in the blank by, and then this particular diagram is going to be by angle side angle. And if you recall how to do this properly, let's say it's DOG, that means we have to follow this pattern, D to O to G. We go through starting at the one angle tick, go to the two angle tick, and then go through the last one. So here, it would have to go from the 1 to the 2 down to the 9. And that would mean we would have to name this triangle TNA. So let's put this in a different color. TNA. Okay, so that is angle side angle. Now, there's the other one, angle side, is our fourth way to prove triangles are congruent. So we could go with AAS, also known as angle side. And when you're using angle side, this states if two pairs of angles and one pair of non-included sides between two triangles are congruent, then actually put non-included corresponding sides. So actually put here corresponding, add this to the definition. Non-included corresponding sides are congruent, then, and let's drop this down below because it has, as we've always done, if then starts a new line, then the two triangles are congruent. So this is actually an important feature, and I'm sorry, I probably should have put that in the first place. I actually might have room to do that. Let's squeeze this in. So let's take this, move this down, just enough space. Let's shrink that down a little bit. So the non-included corresponding sides is actually an important feature. So I'm going to actually highlight this because it has to be corresponding. I'm going to also highlight corresponding or underline it because that's actually a really important feature. First and foremost, let's just draw a triangle, any triangle, and let's call it this one CAT. Okay, if we have angle side, that means we have two pairs of angles that are congruent, and then one non-included corresponding side. So as of right now, there's nothing corresponding because there's no triangle, no second triangle. So I could actually say, well, we know for sure this is the included side. One of the non-included sides is either AT or CT. So it doesn't matter which one's which. If I put AT, if I mark AT, then this follows the pattern angle, side. Now technically I could put one here as well, and I could do the same thing, but in reverse order. Angle, starting with A, angle, go to C, and then go through the last side, CT. So both work. The important part, though, is that it has to be corresponding. So if I mark AT as the side, and I draw another triangle, and let's call this one FLY, then, and I mark, for instance, this here, then the proper non-included corresponding side has to be LY. Because if you look closely, if I were to, yes, this is still, they were both angle side, but it has to follow the same pattern when we go through angle side. So C is the first angle, A is the second angle, and then we go through the two ticks. It has to be the same pattern. One tick, two ticks, one side tick. Now, the reason why I say that is because what happens if I actually change this to this other side? Okay, now technically these both have one tick on them, meaning they are congruent, right? So that's where the non-included sides are congruent. Well, if you look at the pattern, if you go from, for instance, one tick to two ticks through the one side, in this particular case, angle side will look like two ticks to one tick through the one side, and it is not the same order. Okay, corresponding angles all have to line up, and corresponding sides have to line up when we do this pattern. So this one I would definitely kind of keep an eye on, just because it can be a little bit tricky to identify angle side properly, especially with this part, the non-included corresponding side. Okay, so FY, or it should be LY that has the one tick. Okay, so now that we have that, we could say triangle CAT is going to be congruent to triangle, and then in parentheses, or not in parentheses, after the fact, by angle side. It follows that pattern, one tick through two to none, and then with the included side is the last piece. One tick through two, and we could see it. Now, it doesn't have to always be in that order. For instance, we could name this TAC, but in terms of actually like recognizing the angle side pattern, it has to follow that particular order. The triangles don't have to be named that way, is what I'm trying to say. Okay, so triangle CAT is congruent to triangle FLY. Okay, ooh, and angle, side. All right, so there we have it. Two new triangle congruencies, ways to prove triangles are congruent. Ultimately, that leads to this congruency statement, which tells us everything else we need to know about this triangle. For instance, CT is now congruent to FY, as we can see first and third. Okay, so if you do have any questions, please bring them to class, and I will see you in the next one. Bye.